Okay, so let's take a look at Chapter 4, Section 6. We're going to solve equations using a skill called completing the square. This is going to be pretty new for everybody, so I need you to really focus and try the ones that I ask you to try. Okay. First, we have to understand how to solve simply by finding square roots. So we're going to take a look at a couple problems where we're given a quadratic equation, very much like this one right here. 4x squared plus 10 equals 46. And then what we're going to do is we are going to try to solve that simply by getting the variable by itself. Okay, this is the difference here is that usually we have ax squared plus bx plus c equals 0. We can use this when we don't have that middle term, when there is no bx. Okay, and what we can do is we can just get the x squared on one side, the number on the other, get the x by itself, and then take the square root. It's really important. I need you guys to understand that when we take the square root of 9, that could be positive or negative 3. It can be negative 3 because negative 3 squared is 9. So there are two answers. If you were to graph that, you'd see two answers also. Same thing here. We add 5 to both sides. We divide both sides by 3. We get x squared equals 10. And then the square root of that is just plus or minus the square root of 10. We don't even need a decimal. You can just leave it like that. Okay. So take a second, pause the video right here, see if you can come up with answers for 1A and 1B. Pause the video now. Okay, so hopefully you tried these. I added 10 to both sides, divided both sides by 7, and got x equals plus or minus the square root of 5. And over here I got x equals plus or minus the square root of 2. If you got stuck on either one of those, feel free to make a note of it, and we'll go over those more specifically in class. Problem 2, determining dimensions. Okay, so while designing a house, an architect used windows like the ones shown here. What are the dimensions of the window? So we would need to know this area here, and we need to know this. So the area of the rectangular part is 2x times x. That part's easy. And then the area of the semicircular part is 1/2 pi r squared. So it's pi r squared is the area of a circle, and half that is 1/2. So 1/2 pi r squared. The radius, we plug that in, the radius is just x divided by 2. And so we get this equation right here for the semicircle part. So we add those two together, this plus that, and we end up with this right here. Okay. In the problem, it says the window has 2,766 square inches of glass. Okay. So we set up this equation and we solve for x. All right. So we have to just get x by itself. Here we factored an x squared out. That's what they did right here. And we have 2 plus pi over 8. We divide both sides by 2 plus pi over 8. And then in your calculator, you can do this big mess of a problem in your calculator. And you'll notice that they put, about 34, so it's not exactly correct. Okay. Length can't be negative, so we don't need the negative 34 as part of our answer. So we know that it's a positive 34. And then the semicircular top has a radius of 17 inches. You have to make sure we answer the question, so we have to make sure that we say what's what. Okay. So let's try this. The lengths of the sides of rectangular windows have the ratio of 1.6 to 1. The area of the window is 2822.4 inches squared. What are the window dimensions? Okay, go ahead and see if you can set that problem up and try it, and then I'll help you through the answer there. Go ahead and try that now. So I wanted to kind of walk you through this one to make sure you're on the same step as me. These problems are tough for me without a picture, okay? And geometry was tough for me if I didn't draw a picture. So I drew a picture. Here's my rectangle. It says that the sides are in a ratio of 1.6 to 1. That means they could be 1.6 to 1, but it could be 3.2 to 2, or it could be some other value given those ratios. So it's 1.6x and 1x. The area for a rectangle is just length times width. So this becomes 1.6x times 1x. Which is, I don't know why I wrote that, which is 1.6x squared, and that area is going to equal 2,822.4. All right, I'm going to divide both sides by 1.6 to get the x's by themselves, so let's go ahead and do that. We get 1764, and that equals x squared. I'm going to take the square root of both sides, and I get x equals plus or minus 42. Okay, plus or minus 42. I know it's not negative 42, so I know that the width is 42, and then I just multiply that by 1.6, and I get 67.2. So the dimensions are 42 by 67.2. Okay, and that is how you do that. Let's take a look at solving a perfect square trinomial equation. All right. So what is the solution of x squared plus 4x plus 4 equals 25? So here's how we do this. We can factor x squared plus 4x plus 4, and we get x plus 2 squared. We can take the square root of both sides, and then that gives us x plus 2 over here, and then it gives us plus or minus 5. Remember, when we take the square root, we have a plus or a minus. Then I can write two equations. X plus 2 equals 5, or x plus 2 equals negative 5. And then we just solve for x, and we get x equals 3, or x equals negative 7. So this is what happens when we have a perfect square trinomial set equal to a number other than 0. All right? So let's take a look at this one. We'll do this one together. Let's factor this. Hopefully you recognize that this is a minus and this is a plus. So I know it's going to be x minus, and then it's 7 squared, and that equals 25. Okay, and you can check that by doing FOIL. Then I'm going to take the square root of both sides. So I have x minus 7 equals plus or minus 5. Then I'm going to write two equations. X minus 7 equals 5, and x minus 7 equals negative 5. And I get x equals 12, or x equals 2. And I can always go back and plug both those in, and I'm going to get it'll prove itself correct. Okay. So that last problem, we're going to use that same idea to do this skill called completing the square. So what we're going to do is we're going to take for example here, x squared plus bx is not part of a perfect square trinomial, but we can use the coefficient of b to find c so that it is a perfect square. When we do this, we are doing the skill known as completing the square. The diagram shows the model. I'll talk about that in class. I would rather focus on what it actually looks like. Okay, so we can form a perfect square trinomial by dividing b in 2 and then squaring it. Okay, this is a lot easier to see once we get to an answer. The thing is if we add that to one side, we have to make sure we add it to the other. That's the big key. Okay, so what value completes the square for x squared minus 10x? So if we wanted to factor x squared minus 10x, to complete the square, over here on the left, we'd have to add 25. Okay, we add 25, and that completes the square. Okay, we rewrite it as the square of a binomial. So this is just figuring out what number completes the square. This is the simple. So what number do we need over here? So over here, what could we add to this that would make it a perfect square trinomial? And you just divide the 6 by 2 and then square it. So we would need a 9. We would need to add 9. That's how we do that, because that becomes x plus 3 squared. Okay, so we would add 9 to it, and that's x plus 3 squared. Is it possible for more than one value to complete the square for an expression? Think about that for a second. Pause the video right here. Think about that, and then I'll give you an answer. So hopefully for this you put no for 4b, and then you wrote something about the fact that once we cut this in half and divide it by 2, we're not going to get different answers. It just won't work. It's not possible to have more than one value that will complete that. So hopefully you put something along the lines of you're not going to get a different answer, otherwise it's not going to be a function. Okay, let's take a look at, so here's the key concept of completing the square. You're going to rewrite this, rewrite the equation in the form x squared plus bx equals c. To do this, we get all the terms with variable on one side and the constant on the other. Then we're going to divide b by 2 and square it. Okay, and we're going to add that to both sides. We're going to factor the trinomial, and then we're going to find square roots and solve for x. Okay, so this, I would make sure I understood that. Okay, and here's what it looks like when we actually do it. So we have 3x squared minus 12x plus 6. So like this doesn't factor. Okay, but we can make it factor. We move the 6 to the other side. We divide everything by 3, so we get that out of the way because we had a greatest common factor. And now we're left with x squared minus 4x equals negative 2. Okay, Half of negative 4 is negative 2, and 2 squared is 4. So we add 4 to both sides. Okay, so that's what's happening here. In the next step, we're going to factor the left side. It's a perfect square trinomial, so that should be easy to factor. And then we're going to take the square root of both sides, and then we're going to solve for x. We're going to get some ugly answers like this, and that's completely okay. All right. We can replace x in the original equation with these answers, and we're going to get it's going to come out and work perfectly. All right. So let's say number 5. Let's try and do that one. Pause the video right here. Try this on your own. Remember, x is on one side, constants on the other, and then go through the steps and see if you can solve it. Go ahead and pause the video now. Okay, so let's go through this one step at a time. All right, so for the first thing we're going to do is get the x's on one side and the constants on the other. To do that, I'm going to subtract x from both sides, and I'm going to subtract 3 from both sides. Okay, I do that, and I have 2x squared minus 2x equals 6. I notice that there's something that I can divide everything by, so I'm going to divide everything by 2, and now I have x squared. Pay no attention to that noise. There's a very loud hobbit in the room. X squared minus x equals 3. Okay. Now, so we got to have some comfort level with fractions. The b value here is negative 1. Half of negative 1 is negative 1/2. Duh. And then we're going to square that. Okay. We're going to square that, and that's negative 1/4. Right? Let's make sure. I don't know why I just said square that. I'm losing it. These people in here are making me nuts. I'm going to, okay, so we have negative 1/2 after cutting that in half, and then we square that, and we have 1/4. So I'm going to add 1/4 to both sides, okay? So what we end up with is x squared minus x plus 1/4 equals 3 1/4. Okay, and if you want to write that as 13/4, that's fine with me. Okay, let's actually do that. It's a little bit nicer. Okay, now next step. Next step is to factor this. Okay, so to factor a perfect square trinomial, it's just going to be x minus that 1/2 squared, and we still have just 13/4 over here. Okay, if you're not sure how I'm getting this, it's following the steps that we followed on the page before. Okay, from here, I'm going to take the square root of both sides. Okay, so on the left, now I just have x minus 1/2, and over here I have plus or minus the square root of 13, and the square root of 4 is 2. Last step, I'm going to add 1/2 to both sides, and I get x equals 1/2 over plus or minus the square root of 13 over 2. And that's it. And is that an ugly answer? Of course it is. But who are you to judge ugly answers and pretty answers? I'm sure its mother thinks it's beautiful. So that's the answer. Okay? Pay no attention to the noise. Bad kids are everywhere. Okay, so let's take a look at number 6. We can complete a square to change a quadratic function to vertex form. Okay, so if we wanted to go from quadratic to vertex, we could do that pretty easily here. We have y equals x squared plus 4x minus 6. Name the vertex and the y-intercept. So I'm going to do a completion of the square again, just with this part right here by adding 4 to both of it. And then we just leave this nonsense out here extra. I can factor that to x plus 2 squared, and then I simplify this to get negative 10. So I know the vertex is negative 10, negative 2, negative 2, negative 10, and the y-intercept is at negative 6. I know that from the very beginning, and I can check that in my calculator, and it works just fine. So let's take a look at doing one of those. We'll do this one together. So we're looking for the vertex and the y-intercept, okay? Vertex and the y-intercept. Okay, we know the y-intercept right away is 0, negative 6, because there it is. Okay, well let's do vertex form. So y equals x squared plus 3x minus 6. So I'm going to change the way that looks. I'm going to complete the square just with this part right here. Okay, so half of 3 is 3/2, and square that, and it's 9/4. Okay, so that's 9/4. So this becomes y equals x squared plus 3x plus 9/4 minus 6 plus 9/4. I have to do it twice. Okay. This then becomes x plus 3/2 squared, and that's minus 6. This is easily done in your calculator, but we can just change this to 36/6 plus 9/4. Okay. Sorry, I don't know why I did 36/6. Sorry about that. I need a different. I know my mistake. Guys, sorry, I'm all over the place today. If I add 9/4, I got to subtract 9/4. I don't know why I put a plus right there. Because we don't want to change the value. And that's the part, sorry, let me make sure that this is clear. We added 2 squared here, so we subtract 2 squared here. So we're really adding 0 to the right side. Sorry, I went too fast over that, and then I made the same mistake. Sorry about that. So I'm going to change 6 so it has a common denominator. That's just 24/4. So then this down here is y equals x plus 3/2 squared minus 33/4. We got the y-intercept to 0, -6, and the vertex is now -3/2 and -33/4. Okay, ugly numbers, sure, but they work. Sorry about the mix-up there. This video was a little bit wacky the whole time. You're welcome. Write down your questions, bring them to class, and we'll go over them. See you guys later. Bye.